Morning, afternoon, everybody, and welcome to our last but one session of the day, I think. So, thank you for joining us for our virtual GS UK conference, and welcome to Brian Hookenbrook. Hopefully, spelled that right. Who's going to speak to us about nines all the way down regarding Linux and DORA. So it'd be quite interesting. So I'll leave it to you, Brian. Thank you very much. And
Yeah.
this is our session 7E. So feel free to put any questions in the chat. Speak to you later. Thank you.
All right. Well, thank you, Sue, and good afternoon and good morning, and or perhaps even good evening to everybody who's here or maybe watching this later. My name is Brian Hoogenbrook. I work for IBM over in the United States, and while I'm a man of many hats, what I'd like to cover today is based around resiliency. The idea of platform availability and business continuity, which may seem like an interesting topic to try to sneak into the security track, but availability as part of the AIC triad always seems to get a little bit of short shrift sometimes in terms of the focus it gets. Confidentiality has always been way more sexy than availability, but if you don't have a system standing up, then there's not a whole lot you can do with your workload, is there? So I was part of the team that led the charge for 8.9s for LinuxONE. That's the one with the orange stripe, for the record. And it went over so well that we taught IBM Z and ZOS how to do that kind of math as well. So what I'll do is walk you through some of the terminology we use over in the resiliency space, talk a little bit about HA and DR, and then we're going to start diving into DORA. I know DORA has been a popular topic for the past few years as things have rolled into implementation. And now that DORA is live and fully armed and operational, having an eye on business continuity matters more than ever. So I'd like to talk you through what the regs mean in that space. We'll cover what we did in terms of calculating the 8.9s for LinuxONE resiliency. And of course, being an IBMer as part of my employment contract, then I need to mention CyberVault at least once per presentation. So for anyone who was worried that I may not get to that, I will cover that towards the end. I do have the chat window in my left eye over here. So should any questions come up, feel free to yell at me at any moment. I'll be more than happy to make this as flexible and lively of a presentation as I can muster here. Now, I will say LinuxONE an awful lot in this presentation. And again, that's the one with the orange stripe, not the one with the blue stripe. I know that GS UK has rather traditionally been primarily focused on the IBM Z side of the house. So let me assure you that if you have Linux workloads running on your IBM Z boxes, all of this is going to apply over there. And if you're a ZOS person, don't fret too much. You know, a lot of this stuff will translate. Certainly the regulations will apply in both cases. And I am not a ZOS expert. We worked with a whole bunch of SMEs over there to help teach them how to do the nines calculations over there. So there are similar presentations that cover ZOS specific configurations along that space. Now, it can be tempting to think that availability problems look a little bit like this, right? And certainly watching the news lately, we've had some ups and downs in the world very, very recently, haven't we? Sometimes it can look like this, you know, this idea of either the incompetent intern or the malicious insider being the root cause and causing blue screens of who knows what popping up all over the place as a means to knock down your workloads. The truth is, you know, usually those are the attention-grabbing outliers, but you have to plan for all kinds of cases when you start looking at high availability and disaster recovery. And frankly, when a system goes down, we intended for that to happen. A planned outage is by far, you know, in terms of percentile, the most common reason to take down your workload because you do need to test stuff You need to apply maintenance. You do occasionally need to reboot or re-IPL your stuff because that's the way that you pick up new service and get access to the new hardware. And if you haven't planned for those kinds of outages, then I'm not entirely sure what to tell you. But certainly the people doing the hard work will have some idea of exactly how much time that's going to take. And if you don't have a clear path between those folks and the people who try to calculate the nines and determine relative business impact, then there's a fundamental disconnect. Uh, Now, bad things do happen to good systems sometimes. And the idea of a system failure or an unplanned outage at some level of your hardware, software, cloud stack is a thing that can happen. Human programmers are by their nature only human. So if, we are all flawed and occasionally so is our code. It's a thing that happens and we need to be able to design around those kinds of things. Uh, the unskilled intern certainly is a thing that can happen. Certainly in my early days in IBM, I've knocked down test systems by accident because I didn't know what I was doing. And you get immediate feedback when you hear screams down the hallway, don't you? And you have to get through all that kind of stuff before you get into like the security threats and the natural disasters and the kinds of things that make the front page of the newspaper just below the fold of the political news of the day. So at a really fundamental level, when you're starting to design your ecosystem, you need to start thinking about redundancy, and you need to start thinking about redundancy. You need to duplicate as many things as possible so that the idea of a single point of failure is a myth to the extent that it's possible. Keep an eye on potential problems as they develop to the extent that early detection is possible. Getting ahead of problems is always easier than fixing the problems that have actually happened. Make sure that your data is consistent. That does mean routine database backups and having common points of consistency so that should things break, you don't lose, say, extra zeros from your bank account. I know I like my paycheck at the current number of digits it takes up, and I don't want any of those to go away. Nor do I want anybody to get mad at me if new ones start to appear. And then it's always easier to automate these things rather than to let a human do it. Occasionally, humans need to sleep, or so I'm told. So the idea of having automation around this stuff is going to make everybody's lives a whole lot easier. Yes, automate notification, get humans involved as they need to be, but to the extent that you can build automation around this stuff, it makes life a whole lot easier. And certainly as Zed and LinuxONE roll out new boxes, and I have the old, or not old, but the LinuxONE 4 picture here, just because there isn't a new picture yet publicly available of any hypothetical new LinuxONE machine. Just maybe sometime in the next few weeks here we'll have something along those lines. But in the meantime, you can still visualize the orange stripes and understand that really, whether you're talking Zed or LinuxONE, uh, these machines have been meant to measure mean time between failures in decades, right? And we have the the service calls to back up that kind of content, right? For the sheer number of CPCs that are out in the world and the amount of time that those systems stay up and running. And honestly, in these kinds of environments, your workload is meant to be running longer than the hardware, right? ZVM, for example, has had the idea of ghost mobility for 15 years now or thereabouts. Sysplex is over in the ZOS space, and then GDPS for automation and failover in between CPCs mean that intended or not, your workload should be more durable than real life is the net of it. And so we stopped ourselves at 8 nines just because we didn't think anybody would believe us if we claimed 100%, right? Because we know that problems do happen, but not 8 nines was the kind of math that we felt comfortable with. And I do owe Steve Perva from the mainframe enthusiast community a cold beverage of his choice for invalidating all of his 7 nines merge by adding another 9. I'll get it over to him someday. So Zed and LinuxONE have been working on this for a very long time. And that's a good thing, because as the regulations start to catch up to the mindset that we've had for decades, being able to document all this stuff has become more and more pertinent, right? You'll hear other folks in the security track and or in other venues talk about a lot of the other articles that come as part of DORA, the Digital Operational Resiliency Act out of the EU that went live in January of this year and has been giving a lot of folks heartburn in the years since, in the years prior. What I'm going to focus on today is that fourth column, the one that says response and recovery. It's not to say that the other ones aren't vital to making sure that you detect problems, you detect security issues, that you have the appropriate level of monitoring. But from an HA and DR and business continuity perspective, what I care about today, wearing the hat that I have right now, is response and recovery. This idea that if you have an IT business, that you have a policy, that it's built into the work that you do, and that it supports all of the other things that go into the other articles throughout DORA. And so there are, out on the various DORA websites, checklists you can use. I've highlighted just a few things here, but the one at the very top is that a plan must be implemented. You can't just write down a plan. Well, I mean, the very first checklist is please have a plan. And sometimes, that can be a bit of a struggle, because a number of folks to whom I speak say, well, we have Zeds, and that's really all we needed. And I say, well, that's a good first step, but you need to have a documented plan. Write it down and then prove that it works. Test it out. Make sure that you can contain problems. Make sure that you have mitigations for problems. Make sure that you have communication built into these plans, so that stakeholders are notified, whether we're talking cyber attacks or some other form of severe disruption. It does need to be tested. And I know some clients do regular failovers from one data center to another, just to make sure that nothing is going to go awry if they need to put this into action, really fast. They're always testing it by virtue of how their business workflow is set up. So in terms of bolstering that checklist, I can, again, having a mainframe is a really good starting point. Now, in the case of IBM Z, yes, the Z stands for zero downtime. I don't know where the zero is in LinuxONE unless you squint really hard at that capital O. But either way, the same principles apply to the hardware. There's redundancy built in at nearly every level, from processors to caching to input-output to cooling systems, to validation integrity checking of the clocking, to CPU sparing and swap of processor power should one catch fire in the middle of an operation, to the capacity to do concurrent upgrades, for example, and the idea of detecting new devices as they're plugged in. The awful lot of work went into the hardware, and we gloss over that sometimes, because we know that Zed and LinuxONE are really impressive pieces of engineering, and but they've worked so well and worked so well for decades that it's very easy to take them for granted sometimes. But all that stuff is there, and that's just one CPC. So if you're just starting your journey in terms of general resiliency, then maybe one CPC is all you have. You've dropped in a business class Z or a LinuxONE Express into your shop just to get your feet wet. And you can do a lot with that one CPC. Certainly you have the capacity to survive hypervisor maintenance, network outages, or even some degree of storage maintenance, depending upon what you have set up on site. Uh, in this picture, we have an OpenShift container platform running on top of ZVM, and so we do have some degree of load balancing and compute backup and failover for the survival of, say, some applications or web apps that we've stood up for a very basic illustration. But one CPC is good, but we mentioned that the most common form of outage is the planned one, and occasionally you will need to update your hardware because IBM does not rest on its laurels, and so you'll receive new stuff, MCLs that you can apply to the firmware, or frankly, you get a new box and you want to test it out, right? Test it out in terms of your workloads, making sure that it can survive on, say, a new IBM Z17 coming soon to a data center near you. So physical redundancy helps solve a lot of the extra problems. The idea that if one CPC happens to go away, you have backup. Uh, and that's all very well and good, but sometimes problems get even bigger than that. And so that's where we get into Article 12 of DORA. Again, this idea of backup systems is actually documented as part of the legislation. So good that you have a second CPC on that previous slide. But depending upon the nature of your business, or especially if you're a financial institution, the idea of having a secondary site with enough resource to continue business function in the event of a disaster or countrywide power outage, for example, becomes a really big deal, right? And so the language of the regulation itself is a little vague in terms of how far away a second data center needs to be, but it needs to have a different quote unquote risk profile from a primary site. So and I'm going to go full disaster mode here, if a city gets wiped off the map for whatever reason, asteroid or a really, really, really incompetent intern, your data center needs to be far away that it's not impacted by that, right? And testing at scale across geographic distance becomes a bit of an issue, right? Now, a lot of this stuff it is relative. You will, as part of your business plan, have built up, here's the order in which I'm bringing back my applications. And you're going to focus on a lot of the vital stuff first. And some of the drivers are going to be your SLAs and those service level agreements that you provided to your customers in terms of, well, how long of an outage can you reasonably take? And I'm guessing that not to pick on the x86 space, but I'm assuming that a lot of your SLAs are a little bit more granular and perhaps a little bit tighter than some of the things that happen when uh, the x86 cloud providers of du jour might take an outage that lasts for several hours, and they'll fix it when they get to it, right? So a data center by its nature caps at about 5 nines of availability. So put more distinctly, reality is only 5 nines. Your workload needs to be tougher than reality is the net of it. And you will eventually have to bend to things like the speed of light, for example, but I bet we can do a whole lot better with virtualized capabilities than we can with a real concrete x86 box, for example. There are an awful lot of rules dependent upon location and local laws and standards and whatnot, but that these things will govern how well do you back up your data center? What kind of physical controls do you have in terms of power, water, fire suppression, resistance to grounding or electrical problems. I can say that when the IBM Endicott site existed, we were taken down once by a squirrel that got into the generator outside of outside of our offices, and it took out power to the building, and the squirrel managed to take out ZVM development for about a day. This was a long time ago. We're resistant to squirrels now, but sometimes these things are not. You don't have to think about these things in terms of comets. You know, uh, Sometimes really small things can have a big impact, and having redundancy at those levels is going to matter an awful lot. And so, if you're not the kind of person who's investigated GDPS today in any context, I do encourage you to do so because it's meant to operate in terms of automating recovery procedures, providing point-in-time copies. That can be integrity checked. We'll get to that in just a sec. Monitoring systems and storage. It doesn't even have to be IBM storage, although certainly it does work very well with the DS8Ks. And this idea that you can use GDPS to manage data flow and data replication and synchronization across multiple different sites, whether they're metro level or global level, in terms of, keeping your vital business infrastructure at a distance in such a way that if a squirrel or a comet, take your pick, manages to hit one data center, the other one's going to keep running, and nobody's lost any pay as a result. One of the foundational things that comes with GDPS is something called safeguarded copy. And so you have this idea of backups that are stored, usually encrypted. They will be not accessible by any given server, so they're air-gapped and kept away from anybody who might, squirrel or a hacker, your pick, who might try to tamper with these things. Some degree of integrity checking is done against a backup copy, such that you can do data validation and DFIR against a problem that happens in your data center and recover to the last known good copy of the data that you had running. So it's a fair amount that you can do with GDPS, which is why we listed it as part of this initial slide. So what I'm going to do now is pivot a little bit and talk about how we built out what 8.9s looks like in the LinuxONE space. And I do know that keeping an eye on the clock here, I've been talking for a while and I haven't seen any questions come in. So I am just going to keep talking. And while I'm trying not to use my public radio voice and try to lure everybody to sleep, I do encourage you to watch the replay if you wake up and find yourself on a slide that means absolutely nothing to you. So when we were trying to decide what 8.9s looked like, the first thing we had to do was figure out, well, what are we defending against, right? What are the threats to our workload, and how do we draw this boundary? So we included nearly everything we could think of. Yes, natural disasters. Yes, squirrels. Yes, planned outages up and down the stack, and replication failures and stuff like that. Now, I will say that when we did the 8.9s analysis, we did not actually include cyber attack. And the reason for that is that it's more dependent upon the nature of a cyber attack in terms of what recovery time looks like. So we would have had to have scoped out, well, do we include ransomware but discard APTs, for example? If, the next time we go through this exercise, I suspect we'll provide a full enumerated list of the kinds of things that recovery phase is really meant to incorporate. But when I get to CyberVault toward the end, I'll talk a little bit about how this stuff is covered anyway, even if it wasn't included in the initial math. Now, once we had our threats, we had to start drawing boundaries, right? Reality being what it is, you can combine Z with other workloads or LinuxONE with other workloads in a near infinite number of combinations. And because we cannot scope infinity, we had to make some choices. So, we were assuming that at least for this analysis, that you had competent and non-malicious sysadmins, that you did have a data center that was configured for redundancy and for high availability, that you had load balancing as appropriate, that you had a good configuration, and that you included some white space or free space on your systems for CPU, storage, memory in case something went awry, right? Uh, Space that you kept in your back pocket and in case you needed to break glass in case of emergency. We have a fair number of best practices and guidelines, whether we're talking Sysplex best practices, OCP best practices, GDPS best practices, and certainly security guidelines that all were examined as part of this framework as we built it up. Then we had to figure out what the heck kind of software we were going to throw at this thing. So what we ended up picking for this analysis was running a MongoDB application under OpenShift Container Platform that runs on RHCOS under ZVM on top of Prism and not DPM with OSA to back up the networking, running on a LinuxONE box with a DS8880 being your in ECKD as your storage of choice. Now there's a lot of flexibility here, and I'll get to that in a minute. But we started drawing diagrams, and on a per level basis, anytime we added a component, we thought, well, okay, is there a single point of failure here? How often does this fail? What data do we have in terms of service calls? How much data do we have in terms of workloads running? Are there ways to automate? Are there technologies in the platform that will back this, provide backup or provide automation or mitigate any potential hit to this ecosystem such that the running workload, which is in this case the MongoDB, standing inside of the OCP compute node, uh, you know, how would that not survive? And that's where we drew the line at 8 nines, figuring that without storage replication and GDPS, we were pretty comfortable with 6 nines, and then you add in GDPS for storage replication, and then we went up to 8. And so you'll see here that technically our framework has 3 CPCs at 2 data centers. I threw in a fourth one just for kicks. And in this case, we actually have a mix of LinuxONE and IBM Z. We'll get to that in just a sec. Um, Frankly, we included IBM Z as a way to illustrate the presence of GDPS. I'll talk about that in just a sec. But we set this up in such a way such that if you start to, if you need to redirect where you're getting your data from, you can use GDPS to swap from one set of storage to the other pretty seamlessly without really any application taking a hit. And should one or more of these components go away, whether it's a ZVM partition or one of the OCP control nodes, or even a data center, we actually have the free space in this environment such that an entire partition can be stood up again in one of the spare environments, such that we don't expect performance constraints or hits to SLAs. And so, we kind of went down the list and figured, okay, we have the component redundancy at every level that we can think of. Well, assuming that we have a good data center and a plan around that, we're pretty confident we can survive power outages and natural disasters, especially if hyperswap is there. And certainly OCP will handle rebalancing workloads from CPC to CPC based upon what it needs. Certainly, we're ready for any planned outages. And then in case of replication failures, GDPS is there to do integrity checking and help us out with any forensic investigation that we might want to do. Now, that's just one config with a very small slice of software, firmware, and hardware. We issued the 8.9's claim against that particular configuration. And in some ways, it's not unlike what we do with the common criteria, right? In terms of our security certifications, we came up with one configuration, we evaluated the heck out of it. And then if you're going to vary off from that, um, kind of depends upon what happens at that point. So let me say that what if you only have LinuxONE hardware? You're not a ZOS person. You like the color orange. You stuck with the Emperors and the Rock Hoppers. That is actually not a problem because you can actually run a GDPS-K system on a single core inside of a LinuxONE partition. That GDPS can be there in a pure LinuxONE solution. And even if you don't want to go that route, I believe at the end of March, the GDPS team announced the resurrection of the GDPS virtual appliance, which may help to mitigate some of the skills cases if you're a pure LinuxONE shop. Now, if you don't have anywhere, 4 to 12 physical frames, and I can't actually state formally that the Z17 will be cheaper by the dozen. But I'm sure we will send you a very nice gift card over the holidays if you order a bunch of them. But if you only have, a couple, if you have more than one, you're safe from a hardware outage, right? Think about the threat vectors that we're looking at here against your availability. If you are at one frame, then you're constrained to hardware maintenance windows, and we know that those can last a couple hours, depending upon the complexity of what's going on. So if you only have the one, you might need to think about whether that outage is okay or not. Now, if you have KVM instead of ZVM, that's probably okay. KVM does have guest mobility capacity. It doesn't work quite the same way as ZVMs, but it is a reasonable enough thing. At the time I wrote these slides, KVM did not have hyperswap capability. I need to double check as to whether or not that has finally been introduced to the field. I do know that it was being worked on. So if it's not available today, it will be available soon. And certainly I'll go double check these things later on just to make sure that I'm not telling tall tales out of school here. Now, if you're a DPM person, there are some capabilities that really don't function quite as well with DPM yet. So you do need to keep in mind that there you're making a usability versus a continuity choice. And so depending upon the regulations to which you need to adhere, you may have to choose one versus the other. We built all this stuff on top of Red Hat OCP, because we know the Red Hat folks. If you're a SUSE person, there is more than one Linux distro out in the world, and SLES especially is very popular in the European space. So if you're looking at SUSE Rancher instead of RHOCP, I suspect it will operate in much the same way, and certainly it has the same kinds of HA capabilities. It's just that we didn't, include that in the statement that we made. If you want to build your own HA environment that doesn't rely on stuff, all the Linux HA stuff depends upon the same basic set of open source packages, Pacemaker, CoroSync, a Stoneth of a philosophy for taking out things that are causing problems. So you can actually replicate manually what some of these other technologies are already doing under the covers. The downside is that that's a time investment on your part. So did you want to pay now or pay later? Your choice. If you don't have GDPS, you're at roughly six nines, I want to say. Maybe that's good enough, but GDPS does automate a lot of the data copy, the failover, and the recovery that your environment would really benefit from. So consider, the cost of GDPS versus the cost of a slightly longer outage. If and the executives who make the financial decisions, well, I'm sure we'll certainly keep an eye on that kind of math. Again, if you only have one data center, you're dealing with the capacity of reality to deal with the real world. So the cost of a physical site, that's pretty huge, and it's a non-trivial cost, and it's requires a lot of upkeep. But the outage of a data center is also a great cost, and it takes a really long time to recover a data center if even if such a thing is possible. So that is a huge kind of cost of business decision that someone, probably not the sysprog, is going to have to think about. Now, it wouldn't be a DORA presentation if we didn't include Dora the Explorer somewhere. And frankly, I'm a little offended that no other presentation I've had the opportunity to see has included the character who's literally named Swiper in their deck somewhere. Now, preventing cyber attack is not as easy as just saying swiper, no swiping. We need to do a little bit more work than that. So certainly, whether you're looking at the ZOS or the LinuxONE context, you'll notice that IBM is starting to talk up this idea of both cybersecurity and cyber resiliency. To my mind, they're two great tastes that taste great together. You know, peanut butter and banana, or or take your pick. Um, and the kinds of problems that they will tackle will depend upon where you are in what we call the NIST resiliency framework. You know, certainly we have a lot of programs that help you to identify problems, and anyone in this security track will know about RACF already. So the idea of protection of your data, you know, long uh, tea, cup of tea for everyone who's been doing security in the mainframe space for decades. Detection is picking up steam though, you know, with code scanning, integrity monitoring, alert and SIEM adapters that exist both in ZOS and Linux. The idea of threat detection is new, and that is something that we're actually starting to take a look at in the Linux space as well. And then you get into actual response. You know, what the heck do we do now that there is a problem, but we need to get stood back up and running as fast as possible? And resiliency as it was in the past is not going to help you in the case of cyber attack, right? This idea that for example, you take constant backups, but aren't being particularly mindful about them, becomes an issue, right? Because you need to be able to make sure that your backups do not inherit the same flaws or the same modifications that a malicious entity may have introduced. You want to make sure that those backups are protected, that you're doing analytics all the time to make sure that you can recover quickly, have multiple recovery points. Make sure that your backups are protected, encrypted whenever they can be, air gapped wherever possible, so that you can't a hacker cannot go from a compromised system to the place where backups would be located. And then you need to be a little smarter about recovering these kinds of things. So this idea of the cyber vault, primarily a ZOS technology, but being introduced into the LinuxONE space now, is meant to hit all of those things. Cyber Vault, much like pervasive encryption before it, is not so much a single technology as it is a lifestyle choice. So you see a lot of things listed on this slide, and that's because there's a lot that goes into the mindset of being able to do cyber resilient backup and recovery. Again, DFIR, validation, recovery, even in catastrophic times, make sure that you have offline backup, all those kinds of things. So, we talked about safeguarded copy, and this kind of takes it to the next level. This idea that, okay, yes, we had copies, but they can be either virtually or physically isolated from networks, from other administrators, such that you don't necessarily have direct access. So if that day ever comes when somebody figures out just how much money to pay Mark Nelson to to sell out IBM, uh, the keys to the kingdom are reasonably isolated, and the backups, more to the point, are protected from him, such that a compromised, highly privileged insider can be kept away from the things that we would use to recover once we had terminated his access to all the good stuff, of course. And as we look at data validation in the Cyber Vault context, it's worth, minding that yes, safeguarded copy will take the snapshots, and you'll see the Cyber Vault suite, as it were, start to build up multiple different types of backups. You know, type one, really looking at the fundamental infrastructure. Has somebody really broken the workload, down at its fundamental level? We have started doing type 2 validation of data structures. So, double checking that the RACF database, for example, and this would be true in ZOS as well as ZVM, that it hasn't been tampered with, it hasn't been compromised. Are your DB2 utilities, running in such a way that you're not bringing back a database that's been broken? The idea of type 3 validation, where the stuff that you, the end user, are writing gets validated, is still a thing that's kind of in progress. And I think the LinuxONE journey is closer to type 1 than type 2 at the moment. ZOS is more in type 2 and heading towards exploring the concept of type 3. But we understand that it's the full stack that everyone's going to need help with. But you use all this stuff, of course, because anything you can do to reduce the amount of time toward detecting a problem means that you can respond to problems a whole lot faster. And that's a good thing, because Article 11 of DORA has a whole bunch of prove it clauses. These are things that your auditors are going to double check, and you will need to talk to authorities about impacts and yearly damage that are resultant from cyber attacks as well as general outages. And you need to have documented that communication and crisis plan with internal staff and external stakeholders to make sure that all of these things that you're putting into place to make sure that your workload is up and running is going to be okay. And so I'll very, very quickly pivot to the ZSCC, the Security and Compliance Center. You use that today to look at, is my system PCI DSS compliant, for example. We do have some security support for DORA in terms of the crosswalks and the profiles that we have in ZSCC, but you might start building your own. And measuring HA is a neat trick, right? Because, you're basically checking, is it still there? But for example, you could check to see if ZVM and single system image is functioning with no detectable problems. Make sure that your GDPS XDR proxy machines are up and running. Make sure that RACF is there and doing fine. Validate your OCP pacemaker heartbeat. Make sure that GDPS isn't hitting any latency issues. All the kinds of things, and this is not an exhaustive list, that you can use to make sure that your workload is going to be up and running. So I see that I have an entire 50 seconds left. Let me pause and ask, did anybody have any questions?
Doesn't sound like it.
Okay. Well, no. Okay, then I'll very quickly summarize. There's an awful lot that goes into providing business continuity for this platform and the surrounding ecosystem, and you have a lot of tools to help you across end-to-end this resiliency framework. And that's true whether you're on Z or LinuxONE. We don't really care if you're a blue stripe or an orange stripe person. We have red books that can help you in either context. And these do go into a lot more of the details of if you have a framework that varies off of what we analyze in terms of the 8 nines, what do we do and what are the considerations? All that stuff gets documented down at the red book level, even if it's not in the basic math. And should you, in 15 minutes or in 5 days or you, the person listening to the playback months from now, have any questions, I am certainly available. And I'd appreciate any questions. Feel free to throw them my way as you'd like. It is a hat that I am still wearing, and I'm more than happy to help. Please don't forget to fill out your evaluation forms. They help the GS UK folks build a good conference, and will help them determine whether or not they let somebody like me back in next year. But with that, unless there's any other questions, I'll say thank you very much for taking the time to listen.
Thank you very much, Brian. And thank you for doing part of my job for me. It was
Here to
very
help.
interesting. Find it quite interesting, and I'm sure many of the others did as well. But as we are out of time, thank you for your time today, and we'll speak to you soon. Thank you all.
Thanks, everybody.
Bye.